So the prep for 1.7 is about playing with formulas, which we've already been doing a bit right from the beginning of this course. So for example, some formulas we've played with so far, we have y equals mx plus b. We've been using that since day one with the patterns of the dots. We had the blood alcohol, B equals negative 0.015 T plus 2.84 times N, the number of drinks, over weight times gender factor. There's another one that we've played with. Other formulas we've messed with a formula for slope, M equals y2 minus y1 over x2 minus x1. And I've mentioned this before, and some of us have forgotten. If I wanted to type this on a computer, I don't have a fraction bar to work with. I would have to type it in a line. So I have to use parentheses sometimes with this. So when we write formulas, we have to decide when do we need parentheses and when don't we? And it depends on the symbols we're using. So this would be an alternate way to write that. Without the parentheses, this second way using the slash would be incorrect. So sometimes parentheses matters. A new formula that we're going to come across in the prep and the lesson is this one here. Z is equal to x minus, and then we're going to throw some funky letters in here. That letter there, and this letter down there. So the letter in the top here, color, is the Greek mu, mu for mu. So it's the lowercase Greek mu, and this letter down in the denominator is lowercase Greek sigma. So sometimes in different science classes and other places, instead of using letters from our alphabet, sometimes letters from other alphabets like Greek or Roman are thrown in there. In math classes, when the Greek letter mu comes up, it usually means an average. So mu is an average, like average height, average age, average GPA. Another word for average is mean. You might remember for some previous math course, maybe high school, looking at data and finding the mean, the median, and the mode. So mean is average, and that's what this Greek letter mu looks like. It's kind of a cross between an M and a U. It looks like a scripty M, or it looks like a U with a tail. The other letter down there, different color, sigma, is officially called standard deviation, which you may have seen in a previous math class. If not, after this class is Math 105 or Math 111. This comes up in Math 105 and in statistics. Standard deviation talks about the average spread of the data. Average spread. If sigma is a small number, the data is all near each other. If sigma is a large number, then the data is really spread out. So mean is the middle of the data set, and sigma talks about the spread. And other things here, Z is just a letter that's called a Z-score. So Z is called a Z-score. And what a Z-score does, and we don't have to know this, all we have to know is it's a Z-score, but basically it counts standard deviations. If I could spell correctly, counts. And then X, the last variable there, is just some given measurement. I'll give an example of this. So we've played around a lot with y equals mx plus b. We've played around a lot with the slope. We've played around with the blood alcohol equation. So there's going to be some prep and lesson examples that deal with each of these. So that's kind of a review. And then there's a couple of new formulas I'm going to throw at you to play with, this being one of them. So let's do a quick example of that. And And then we'll be just about done for today. So I'm using that formula, z equals fraction x minus mu over sigma. And we might be given some information like, let's say we're doing heights of males. And we're told that the average male, say in Oregon, is 68 inches tall. And then we would be given a standard deviation. And let's say the average spread for males in Oregon is 3 inches. And then what I could do is I could find the z-score of a male who is, let's say, 70 inches tall. So to do so, I'm trying to find z, and my formula already says z equals, and then I just plug in what I'm given. So average, well, that right there must be my mu. Standard deviation, that's my sigma in the formula. And the measurement of some individual, that's what we call an x value in this formula. So I would just enter 70 minus 68, right, x minus mu, and then divide that by 3. So 70 minus 68 is 2. Divide by 3. I could leave it as a fraction maybe, or we could convert it to a decimal, and my calculator would say something like 6.6666667 would be the answer. And maybe I would plug in like 4 or 5 decimals if I was going to do the decimal answer. Other thing we might be asked here in a problem that's a little more complicated is to solve. Like maybe we're given that z is equal to let's say 2, and then we have to figure out what x is for this situation. And so we might have to solve an equation like that. Last thing you're going to come across in the prep is a reminder of the distributive property. And I'll just draw a picture of what the distributive property tells us. Okay, so I tried to draw a rectangle here that is 9 by 3. But I put this divider in there. And what the divider tells me is that there's 2 rooms here. This room, the first room is 4 wide, and the second room is 5 wide. And the way the distributive property works here is this whole rectangle is 3 high no matter how I look at it. So I could say this is 3 times 4 plus 5. Or I could say this is 3 times 9. Now, this is 2 different rooms here. So another way to look at it is there's one room that's 3 by 4, and there's another room that's 3 by 5. Order of operations at the top would tell me that I have to do what's inside the parentheses first and get the 4 plus 5 equals 9, and then I can multiply the 3 times 9 and get the 27. But if I look at it as 2 different rooms, I could say it's 3 by 4, which is 12, and 3 by 5, which is 15, and 15 plus 12 happens to be 27 also. Notice we get the same answer regardless of how I look at it. And this is an illustration of that distributive property, that if you have a multiplication outside of an addition, then you can distribute through. So there's a couple of problems to remind you of this distributive property. And so an example of something you might see in the homework would be maybe you have 2 times 3x plus 5. Another way to write that would be to distribute this 2 multiplication through as 2 times 3x plus 2 times 5. Some people skip this second step and just say 2 times 3x is 6x, and 2 times 5 is 10. So that's an example of the distributive property, which we're going to need in the lesson. All right, so that's it for now. We're about quitting time here. It is 1:40, time to get some lunch, move around, shake a leg. So good luck on your homework and the prep. Message me if you have any problems, and I will see you on Wednesday otherwise. Thank you all.